Cool. All right. Should be live. Hopefully everybody can hear me. Maybe someone in chat can let me know if it sounds good. Started a little bit early, so assuming there aren't many people around just yet, but that's okay. If you are around, go say hello. And hope you'll enjoy today's stream. We're continuing where we left off earlier in the week when I worked on this beautiful little bit of logic around procedural animation for a character that walks around. Hey, GB, how you going? So this was my first attempt at getting a walking animation going, but completely procedural. And obviously, we're only concentrating on the walk. So he's pretty stiff on the upper body, but that's okay. Really should do something with the arms as well eventually, but that'll come. Oh, cat, what are you doing? 1 second. I just need to chase my cat away from. Oh, she's figured it out already. That is not good, cat. That's not for you. Hold on for a second. I just need to take care of that. Oh, right. In a second. What are you doing? What are you doing, baby? You good? No, you're just running around. Okay. Anyway. Problem solved. Hello, Amir. How you going? Sorry, I just needed to help. I'll take care of my cat. She was jumping on top of tables where she's not supposed to be jumping on. All right. So yeah, we got a little guy walking around. I'm actually planning to redo what we did last time and just improve on it a little bit. So taking this as our very first example, especially also doing something about the craziness when he's turning. Although I'm not quite sure how much I can do about this because this is not a natural turn anyway. But obviously I'm not limiting the turning based on anything. We can do crazy stuff. I don't think that will ever be able to do a whole lot with that. Unless if there's some crazy turning that we cancel whatever we're doing walking wise and just put our feet back and go into some sort of turn animation, I guess. And obviously the running is not working the way that it should, but hey, it's the first try at this, so we are going to see if we can start over with everything that we've learned here and slightly improve on it. Now, before I do that, I do want to change a few other things. This is obviously a nice little test room that I created for other purposes, in which I happen to create this little test project. So we're going to start with a simpler test scene for what we're doing. Hey, Rodzilla, how you going? Nice of you to join. So yeah, let's do that first. I just want to make a simpler test scene that's more open, and that we can actually properly look at our character and go from there. And I'm probably just going to make my life easy by just starting with duplicating the project that we have and then going from there. So we're just going to go and say duplicate this. Yeah. Always blame everything on autocorrect. There we go. All right. So we're going to take the room out of this one. Hello. Now we have a nice empty environment. Now we already had our floor. All we need for a floor is a mesh instance. Ta-da. You're going to go give that a very simple standard material. Oh, I need to also give that a shape. So we're just going to make that a plane mesh. We're going to make that nice and big just so that we have something to walk on. Do I already have my... No, I don't. So I need to quickly copy that in place. Bear with me a second. Any idea about the next Godot XR game jam will be? Let me check. Because we have a broad idea. We wanted to move it past the holidays. Let's see where we were last discussing that. Gotta scroll down quite a bit. There we go. Yeah, August, September we were thinking about. So late August, early September this year for the next one. Okay. Bear with me while I copy a file in place. Let's go. No. I've got too many folders. I can't see the wood for the trees anymore. Probably should be one in here. Nope, not in this one. Yeah. Wait, that should be one of my tutorial folder. Yep, this one maybe? Nope. This one maybe? Nope. Where did I? Come on, I've got this file in almost every project that I have, and now I can't find it. Here we go. So now I need to copy it into this project. There, here. There we go. All right. Where is this guy? That one. I hope they fixed that. Oh, they probably fixed it actually in master already. I'm still on 4. I should really update to 4.1, I guess. It always goes to the wrong part of this when you fault something. We go, yeah. Why is that not linked? Yeah, that looks all right. We give it a different color? Let's give it a different color. Something like this. Yeah, why not? Good enough. So now, of course, I need to go and change that to now open up test 3. Now it didn't do that. Why not? Probably because I didn't save. Yeah, wasn't. Oh. And then in this one. Yeah, that's fine. That's fine. Oh, I don't have my. Yeah. Let's go ahead and add a sun and an environment into our scene, shall we? I might actually get to see something then. Here we go. All right. So now we have actually got a little bit of space to walk around with, and we don't easily run into a wall where we can't see what we're doing. But yeah, okay. So simpler, nice little environment. Let's go and actually have a look at our setup here. What did I do in here? So this is purely all that stuff. Cool. So I've got a ground collision and a body collision. That's actually something that I'm planning to change. In this case, I'm actually going to take out our raycasts. I know that's what we did to make sure that we could go up and down the stairs, but I want to change the way that works. Probably means that I need to change the color code here. I think so. We can just take that out. Okay, so with that, we should no longer be able to walk up our stairs, but that's okay. So yeah, we get stuck on our stairs. And that's fine. Cool. Because if my idea works, we're going to solve that in a different way. Ooh, is fragment density map support in Godot 4.5 Dev 2 something Godot XR Tools should support? Has nothing to do with Godot XR Tools itself. It's a It is a feature that should automatically be used the moment that things start. There is already a line of code in XR Tools, I believe. Let me double check that. And of course, it's only if you use the mobile renderer. If you use the compatibility renderer, we're already using foveated rendering. But come on, open up today, please. All right, here we go. Sometimes this thing gets stuck for some reason. Okay, where are we with the standard startup scripts? Is that in staging? It might be in staging. Nope, it's not in staging. And it's in XR. Yes, it is. Start XR. So the only thing really that is important in here, if I can find it. Oh, where's the setup here? Is it in here? No. Then it's in. No, it should be in here. Did we never put it in here? That will be might actually be an open PR. We might have actually not yet put that in here. So your remark might not be too off the too wrong actually. All right. I must have still got an outstanding PR for that. I'm not sure why I never finished that. Yes, it's this one. So the bit of code that needs to be added is this little bit. So what we're doing here is if we have a rendering device, that means that we're on the mobile renderer or the Forward Plus renderer. We need to enable VRS mode is VRS XR, and that will automatically select fragment density map support if it's available, or else it will fall back on the standard fragment rate shading. And they should both work. If you're on the compatibility version, it simply gives you a warning because that is controlled by. Where are you? OpenXR. And actually, I don't even have it turned on. So if you put this to high and this to medium, that's the settings you should always have. If you're using a compatibility renderer, right now I'm using the Forward Plus renderer. I'm not doing anything XR related. So this wouldn't even be taken into account. But this enables the built-in OpenXR foveation on devices that that supports it. But we only use that on OpenGL because our Vulkan renderer does things a little bit more complex than what OpenXR easily supports. So we have our own implementation of it. But yeah, if you set the VRS mode to XR, then it should just be automatic. There is another PR coming from David that allows the XR runtime to give us the density map, and that makes it even better. So we're continuously improving on that logic. Okay, back to our subject. So we have our avatar here, and I'm actually going to delete that for now because I'm going to duplicate our avatar. Duplicate, and we're going to create and call that avatar 2. There we go. All right, and now we're going to go and drop that in. There we go. Boom. So now we have our avatar back. Should still work the same. Let's actually rename that avatar 2 just so that we know the difference. Okay, and that also means that we obviously want to duplicate our script. Eventually, if this one works better than the first iteration, we're obviously going to remove the first iteration. But for now, I do not want to lose the original implementation. There we go. Because I want to be able to look back on that. Now, we're going to strip out everything that we've done except for our IK logic. We're going to get rid of all the settings that I created here. Oops. I'm probably just going to keep the hand stuff in there because I'm doing some of the IK stuff in there. Obviously, we're going to go and get rid of all of these. We might reintroduce some of those. But now I want to get rid of them all. These I do want to keep. This obviously goes away because they don't matter anymore. Means that we're also going to go and get rid of our UI here. Might keep our little debug thing there. Oh yeah, that's just a little foot placement thing. All right. Left target, right target. We want to keep all that. This we're going to get rid of. There we go. We're going to get rid of those. We're going to keep that. We're going to keep that. We're going to get rid of those. We're going to get rid of those. And I think that we're going to get rid of everything here. Yep. Everything from here. Probably much of that is going to return, but boom. All right. So if we now run it, we have our character, and it should still work. Oh, that's right. We had it 180 degrees turned around. We might actually fix that up in here. Okay, so let's turn you the other way around. That also means that we need to change all these because they are all flipped around now. So that becomes minus, and that becomes minus. And then probably the target we need to adjust as well, but we'll see. That actually becomes plus, but that becomes minus. Then that becomes minus, and that becomes plus. Okay. All right. Cool. Let's reopen that and see if... Okay, we got everything turned the wrong way around. Woo. That was to be expected. So let's start out with these guys. I'm just going to rotate at 180. Do the same with this one. 180. And we're going to do the same with this one. No, because that is already rotated around a different thing. Okay, that's 180 on that one. There we go. I'm going to guess that that one also needs to be 180. There we go. Perfect. All right. So I'm using these targets to update the positioning properly. We should also have a look at whether our... No, those were rotated along with it. That's cool. But that's not a problem. Cool. So far, so good. All right. Yeah, okay. So let's see if that now looks correct when we run it. Yeah, we have forward, backwards, left, right. We still got jump. Oh, can we jump up the stairs? Jump. Oh no, I disabled the jumping or the movement while jumping, and I'm not keeping momentum. Oops. Well, we could quickly fix that. Just character body. Oh, that's a good one. I didn't duplicate this guy. So, hey, that's a shame. Can I undo all the changes that I did here? Yes, I could. Can. Is that all the changes that we did? Yes, it is. Okay, so if I now go back and open up task 2 and just run that scene, is that one still working? Yeah. Okay, cool. All right. which now means that I need to go and duplicate that. So we're going to make that character body 2. Okay. Not confusing at all. Let's clean that up a little bit. Let's close you. Let's go here. Let's go. Let's say you load character body 2. There we go. Save. This one's closed. Oh, it doesn't do that automatically. That's a shame. All right, and now we should be able to delete this. Is it offset used somewhere? No. It is. Oh yeah, we were offsetting that. Okay, cool. No errors and moving. Yay! All right, we broke everything and removed everything that we did last time. This is probably going to be something separate to XR tools. But I might add it to XR tools too, maybe, or I'll add it in a way that it can work properly with XR tools too. What's wrong with my? There we go. But it's probably going to be something separate. But I first want to get it to work and see if it's good enough, or whether it's just going to be something that I'll do. I don't know, just a demo app for that people can look at the source and then adjust it the way that they want. We'll see. Too early to tell. So, all right. So if we're jumping, we're adding something to velocity. All right, and if on floor we do that. So we're actually going to do that if we're on the floor, and if we're not, we're just going to keep our momentum. So this is going to be a drag coefficient calculation. There we go. And we need to do that as an export. Drag, what do I call it? Drag vector. All right. And it's the same for Z. Let's see if that does what I hope that it will do. Yeah, we're gonna have some jumping. A tiny little bit of slowdown. Okay. See if that's enough to, yay, get up the stairs. Oh, I need to keep some momentum. Okay, not quite obviously what we want, but we can get up the stairs by jumping. At least something. All right. So important for this is that every bit of code in our character body is just normal movement code. There's nothing special about this. It's loosely based on the standard code with a little bit of extra sauce in there. Our mouse capture, our rotating of our character, that sort of stuff. Might want to lower our rotation speed maybe a bit, just so that we don't get, yeah, so now maximum rotation is a little bit better. Okay. Oops. There we go. Cool. All right, now we need to start making our avatar move again. Yay. All right. All right. First thing that I want to do, oh, I need to go into avatar for that. The first thing that I want to do is we're going to move this down. There we go. And the same with this one. Let's go and just put that over here and then just move that up. Whoops, that was too far up. Come on. So I want to put these here because I don't actually want them attached to the targets. I want to place those where we're actually doing our movement to. I might actually also rename them and not say left foot, but on ground, debug, and off ground, debug. So these are going to show our targets of where we're moving our feet. Okay. Good enough for now. Okie dokie. Oh, that's because it always does that. So annoying. Just reopening it so that our targeting stuff is working good. All right. So let's go and get our basic walk cycle going. But the thing that I'm going to change now from our previous version is we're going to make a bigger focus on one foot being on the ground and the other foot moving. Now, if I'm standing still, then this foot is on the ground. This one is moving, but we're standing still. So basically in the frame that we're checking that, we're saying, where does this foot need to move to? Oh, and where it is. And then we swap which foot is on the ground. So now this foot is on the ground. Now we're still standing still. This foot, we're going to determine where we want to go to. Still in the right place. It's going to step there. Now, once I start moving, then I'm going to say, where does this foot need to move to? This one's on the ground still. This one we're going to move. So let's say that needs to move over there. So we're going to determine where that place is that we need to move to. We're going to keep adjusting that as long as our foot is not on the ground. And in the meantime, we're going to move that foot to make that step. And depending on the distance that we're moving, depending on the speed of our character, we're going to determine how fast that step is going to be. So that's going to be a factor of our movement speed. We're probably going to make that something that we set to a certain time interval for now, just to get the logic going. But then we're going to start adjusting that time interval depending on whether we're standing still or whether we're walking or whether we're running. And that should also mean that the running should be, we should be able to get it in such a way that we really looks like that we're running with our feet going off the ground. So I first again want to get that step mechanism going. We'll also want to make sure that this time we're going to get the rotation in there, and see if we can get that logic to be there. It also means that I really do want to have a enum here. How does that work in? Is that like that? Yes, it is. Left foot, right foot. Okay, let's call that actually feet. Just easier in code to do it that way to determine what we're doing. I'm even sort of wondering, should we get some help or things there as well? Okay, we might add a dictionary of a class there. We'll see. All right, so another thing that I really want to do here. Is complaining about. What? Okay. Don't care about that. Okay, I'm just going to make that. This is one of the things that I don't really like too much about. Yeah, I'm just going to have to do that. So I've been using gdlint as a linter, but it doesn't really like to have multiple sections where you have variables code. Really need to figure out if there's a syntax in there that it does allow you to do that. So this is going to be k. Let me make that private. K functions. Okay, let's see if that looks proper. So that's our update left and update right. That's cool. Let's also go and make that a code group, and that's going to become our hands export variables, just so that we can collapse the things that we don't really care about right now. And then we're just going to make that a code group and make that our already. There we go. And then this is going to be built-in functions to clarify the dots, the Godot stuff that we're overriding. So now we can make a region for ourselves. Well, we're first going to define a function for what we're going to do. Let me go and open our original one. Oops, in. After. There we go. What do we call it? Yeah, make target transform. Let's go and just copy that for now. It's probably going to change. We're going to keep some of that. Okay. Procedural functions. There we go. Okay. So we're going to go and need that. Cool. Cool. All right. Okay. So turn you off. There we go. So now we're going to go and see what our left foot, right foot stuff is going to be. Now, do normal variables go before or after unready variables? I believe that they come before. Put on ground is left foot. Okay. Let's assume that we start with our left foot on the ground. Oh, that is feet, not left foot. Thank you very much. And let's make a code group for that as well. And we're going to call that walk. What do I call the functions? Procedural walk private variables. Doesn't really matter what we call it, but it's just so that we have them all together. All right. So, because we're moving our character forward, we're still going to have to make sure that the foot that is on the ground needs to keep getting its last known variable or location, and the feet that's in the air, we are going to move. All right. I think actually that we're going to around left. Oops. We're gonna do the left. Go on keyboard. We're going to the left foot, and now we're going to do the right foot logic, which is actually just going to be calling a function that handles one or the other. All right. Last on ground transform, because that's the one that we always need to remember. And that one we are actually going to calculate over here and say that is going to become our default foot dot. Oops. All right, just double checking here. Are we indeed working on the basis of, yes, we are. Because that's similar to what we did before, but I'm going to be doing it slightly different. So the foot that is on the ground is going to get that, and the foot that is in the air, we're going to move and update. All right. So first thing that we're going to do is position on ground. And that's going to be default left foot. So we're going to give that the foot that is currently on the ground one. So we're going to do that the same here. Say, right. So the foot that's always on the ground stays where it is. We're moving the character forward, so we need to place that back where it is, because that obviously moves along with its parent. Unless we make that a top level thing, it's also possible. Could do that. Could be worth making that top level, actually. I actually like that more as an idea. Yes, I like that more as an idea. And then we actually don't need you. And we don't actually need this and this. We don't only need to move the foot that's currently being moved. So what we're going to do now is we're going to say default left foot dot top. No, is. Why is that not working? Okay, are we just going to make that an on ready var then? Oh, where are my on ready variables? Here we go. So on ready var left foot target node 3D is default left foot. Actually, come to think of it, I'm overthinking this. I can just tick that here. I can actually make that a top level right away. Especially seeing that we're doing it in editor anyway. So yeah, that's now not adjusting yet, but that's fine. No, that is the reason why I don't want that to become top level until we actually going to move it. And again, if I do that on ready, it's going to change those anyway. Nah, let's keep them on. Let's see. It's going to be fun when we place it, because that means that seeing that we're in editor logic, the moment that we do this, we should see it starting to move that in place. Now, for some reason, is that because we haven't reopened this? No. Test 3. Oh, what? This whole character body is swapped around. All right, that means that I actually do not want this logic to work in editor. That was nice when I originally was playing around with that, but that's really overkill right now. So we are indeed going to turn off is top level. We're going to turn off is top level. So we're in the right position now, which means that in here, it should be in the right position. And we're only going to make that top level path. We're also only going to run our logic here if we are not in the editor. So we're going to check if engine.is editor hint. We're going to set process false. And we're going to say return. Do not run this in editor. And in this case, run the rest in editor. And then we can go over here and say, were we adding those in? No, yeah, we were, and I undid that, but I am going to still do that. Is left foot target. No, 3D is default. Left foot. Right foot. Targets. Leave the right foot. I'm still wondering if I should rename these nodes. But I'm still assuming that we might eventually have an overrule for the left and right foot. If we have an overrule for the feet, we're obviously going to disable the automatic walking logic. But in that case, those names still make sense. So here we're going to say is it just top level? I always forget. Top level true, right foot target, top level is true. Okay, so that means that when we go back here, our feet should still be fine because we're not moving them when we're in editor. But when we run our game, they should start correctly. But when we then move, our targets stay where they currently are. And we don't have to keep updating their position, which is really cool. Ying, ying. Yeah, that's pretty neat. Okie dokie, cool. So, that actually also means that for now, we want to also do top level. We want to do the same also for our debug objects. So they should now also stay where we are. Cool. Now we can see what we are doing. I also want to change the colors of these things. So the one that's on the ground, we're going to make red. No, we're going to make green. Where are we here? Well, it's kind of already a green. Maybe a little bit more green. And then the one that's off the ground, that one actually I really want to stand out a little bit more. So instead of blue, that one is going to go for a nice red. All right. So, a little pinkish, but good enough for what we want to do right now. All right. Let's start working. So now the nice thing is, why did I call that foot on group instead of ground? I said that it was ground, but I actually want to change that. I'm going to say, I'm going to make that actually in error. So we're going to say, which foot are we currently moving? Foot in there. Boom. Or maybe I should even name, maybe I should even name that foot moving. So which foot is moving? All right, so if our left foot is moving, we're going to update our left foot. If our right foot is moving, we're going to update our right foot position. And the nice thing now is that once our foot lands where we want it to land, we can automatically update what we're doing. All right. So that should make the logic quite a bit simpler than what we were building before. So I'm still going to keep my target transform, but we're going to make a new function which has move foot. And we're going to say, which foot are we moving? And what is the offset of that foot? We want to have our velocity. Actually, we want to have our linear velocity. And we want to have our angular velocity. All right, and that does not, that does not return anything. Cool. So we first need to go and calculate our linear and angular velocity. It's kind of the same as what we did before. I'm actually going to make that normal private functions. Oh, those are functions? No, variables. So that actually needs to go above here. For last position vector 3, and we're going to have a last rotation vector. No, we're going to make that a Turnian. Okay. Does it really need to be a quaternion, or can we just keep that a transform? Or do we just do it last? Oh, that's actually better, actually. Why don't we do just last transform? Then we have all the data that we need. And we can do with it what we want. So obviously in this case, we need to make sure that we have an initial value for that. We need to remember where we're coming from. All right, then here, obviously, we're going to again do global transform here, but not before we calculate our velocity and stuff here. So var velocity is going to be global transform minus, sorry, not global transform, global position minus last transform origin divided by delta. And I actually want to make sure that we call that global velocity. So we know that that is the velocity in global space, not in local space. I think in this case, it doesn't really matter. Does it? No, we want to go and convert that to local, I think. But for now we have it. Okay, so now we also need to do the same thing with our rotational velocity. So first we need to calculate what our rotational velocity is. And that is fairly simple. That's where we end. I think. Oh. That is the inverse of that. So that gives us a basis that is the rotation between what it was to what it is. Might be the other way around. I always forget that. But that should be the rotation from where we were to where we are now. And then from that basis, actually, let's go and type these. This one also. There should be a option to get our Euler things from here. Yeah, we have that, but I actually want to change that. Excuse me. That's a good one. Does that cancel each other out? That doesn't make any sense. Because I want both my velocity and my my rotation to be in local space. But I want to calculate it in global space because our character might have, whatever it's standing on, it might have moved as well. So we eventually want to know what this is in local space. But does that mean that we're going to have... That might actually suggest that this needs to be the other way around. Because I think if we want to have that local, we actually get something like this. But I get the feeling that we're doubling up somehow. Or does that only work once we have our rotation vector? Or no, I think in this case, it actually doesn't matter whether that's global or not. Because in this case, it is... Well, let's just see what comes out of there. I think because we're having a difference in rotation here, that is actually already localized because we've got them both in there. Okay, let's just make that assumption and just say this is going to be angular velocity 3 delta basis getular. Perfect. And I'm wondering if we actually need that as a basis or if we need one to get that as Euler, because I only care about the Y rotation. I don't care about any other rotation at this point in time. So near velocity 3 is global basis inverse times global velocity. All right, so now we have it all local. Perfect. Linear and angular. Good enough for me. All right. It should already be set correctly, but just in case, global transform is left foot. Transform, because we're snapping with our left foot. I guess we could do like a randomizer at some point. Do we start to walk with our right foot or with our left foot? Right now, it's always make it. We're going to start with our right foot. Sorry, no, we're going to start with our left foot. So I actually need to do this one is on ground. Is going to be, oh, it's actually going to be our right foot. Okay. So, no foot. Oh, and of course, I want my delta in here. All right. I'm being old-fashioned with doing p underscore. I don't know. So we're gonna go and do our left foot, which is left foot targets. All right, so now always forgets. Oh, we do want our foot offset. And left is positive and right is negative. Although that could now have been the other way around because we rotated everything. Let's see. Yeah, so left is now negative. Okay. However, I do want that variable for that. So, no, that's not a var. That's going to be hands. Okay, let's go and do this. Yep. Right. These are the normal ones, and here it's going to be export bar. What did I call it here? Photo set. It's 0.15, good enough. Yeah. All right. So that's going to be vector 3 minus field offset 0, 0. Okay, then we're going to have linear, really? Linear velocity, there we go. Angular velocity. There we go. Okay, now the other thing that we could be doing here. No, we need to keep the delta in here. Okay, yeah. Okay. Delta. Yeah. In this case, we're going to say right foot target, and that's going to become a positive offset. Yay! All right. Okay. 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 All right, let's ignore our angular velocity to begin with. I first want to get it working on our linear velocity. So what we're doing here, actually there's one more variable that we need, and this is the one that we may eventually decide to calculate instead of do this, or variate depending on whether we're walking or not. I'm going to make that a range. Minimum is going to be that. Maximum is going to be that. And I'm going to step in steps of 1. All right. So the idea is this is going to be the time that it takes to make one step. Now, when we look at a character, when we're making one step, we're basically starting where, because we're walking there, and then we're stopping there, and we're taking that step forward. So it's that duration that we now have. So we're going to say it takes the character 1 second to move his feet up through the air and there, all the while that the character is moving forward. All right. So our target is going to be whatever the character can move forward in half that time, because we're always going to have a target half the position forward. That's going to still keep moving forward as we go, but eventually our foot should catch up to that place. And that should, in theory, work. All right. The only challenge is going to be is how are we going to make sure that we know when we've reached that place, but that's a problem for later. All right, so in this case, we're going to start with our target transform.origin is our offset. So that stays the same as before. Now we've got our linear velocity in local space right now, which is very nice. So we can say origin plus is linear velocity times feet step time times 0.5. We want to know how far do we need to move forward from our center position to get to that position half a step forward of our character. Start with our offset. How much forward we need to move. And then we also want to do come on, how far do we rotate? And that's going to be a rotation of the whole transform so that we also get the rotation of the foot at that point. But we'll do that later. And then finally, we return this in global space, which actually we can just do global transform times target transform. So we return this one in global space. All right, so now we can say is make target transform be offset, be linear, be angular. Let's actually put some move. Actually, let's not call it p which, but p foot. Move our foot towards our target. Linear and angular velocity should be okay. Hi LMG, how you going? Determine where we want to place our foot. Linear and angular velocities, local space, returns location, local space. Cool. Although maybe I will not do that, and I will just do that here. Let me just say everything local space. All right, so the first thing that we want to do is we want to go to update our debug. Oops. So here we're going to do off ground debug dot global transform is target transform. Okay, boom. So we are going to just place that debug thing over there. And now we need to move our foot towards that, where we're going to look at how close we are to where we need to be. And then just move it there. For now, I'm just going to move it linearly over the ground just to get us started, but we need to do that arching again. So yeah, let me think. What is smart here? Or do we use our time delta there? That might be a good one too. I think that might actually be a good idea. Yeah, I think I'm going to do it like that. So that means that we need also our time actually, no, I want to do that as min time plus delta. No, that needs to be oops. What did I call that thing? No, feet. Step time. All right. So we're going to increase time until we hit step time, and then we're just going to say, okay, we hit max. All right, and then we need to calculate a factor from that, which is going to be time divided by step time. All right. Yeah, this is where I was thinking that I really don't want the. Let's just keep the P in there. Why not? Old habits die hard, I think. All right, so now we're just going to lerp our foot from where it currently is to our target using our factor. So this misses out on our lifting our foot up. This is purely going to move our foot on. Oh, Jesus, I have the hiccups all of a sudden. Let me get some water. I'm just going to move the foot over the ground. All right. Okay. The other thing that I really want to do is that if we suddenly reverse direction, we probably have to bring our foot down so that we never can move our foot further back. But I need to figure out what the best logic for that is. Not going to worry about that right now. So here we're going to do that in 2 steps, I think. Because I don't think there's a lerp for a whole transform, but maybe there is. Transform 3D. Do we have a lerp for transport? I don't think so. No, it doesn't look like it. Do we have a lerp on bases? Don't think so either. No, we do. We have a slurp on bases. Okay, cool. So let's start with the foot dot transform dot origin is hey Blake. Is there any detail? Should be some from your left. Target transform dot origin, and it's going to be factor. And we're going to do the same thing with the bases. And that is then slurp target transform dot bases factor. Yeah, things happening. We're just trying to figure out things and hopefully figure out what it will do. So here's our character. So now we can already see that as we're moving our left foot. Now the thing that I already can see that I've forgotten to do, it is messing that up right now. I wonder why it does that. That makes no sense when we're recalculating all the time. I don't know why it suddenly flipped around. We're not limiting it by 1. So once we have hit 1, oh, that's probably why it's not calculating anything anymore. Okay, so once we've hit past this, we're never going and swapping around. So we've got our feet set now. So what we're going to do now is if time is 1, so we've reached the end, we're going to do the flip around. So at this point in time, our on ground debug is also going to become our target transform. And then in the next frame, we'll update our off ground because we are swapping around. And And now we can say if, okay, we actually, that's kind of, probably need to, you know what? We're just going to say return true, return false, which means that we need to change our void to a bool. All right, returns true if we finished our movements, which also means that we could do extra logic when we do finish. Right foot, so we change the right, and here change the left. Oops. So one thing that we could do now is we could do further logic here when we finish our movement to maybe change certain settings that we don't want to change mid-step. All right, let's see if that does something better now. So right now, because we're standing still, it is just going back and forth. It's actually going way too quick. I think our second, oh, this is probably one, again, our issues with this being open. There we go. That was that problem. Okay, that's probably also a problem here. Feet, hands, no, that's all good. So let's see if that makes a difference. No, it doesn't seem to make a difference. All right. All right, so one of the things that we can do just to debug this is that we're not going to be updating our time. So we're going to keep our time 0. That means that we should not be doing anything. So we can see that we are twisting. Foot is going wrong again for some reason. And we can see that our target is kind of doing what I would expect it to do. Figuring out where we need to go after a minute. Oh yeah, and we should really have our target transfer, our debug thing slightly up, but not gonna worry about that too much right now. We probably just do that on the mesh. Don't we have a Z offset in here? Would it be on the geometry? I think so. No, where is that hiding? No. Yeah, I think this one. But I'm not sure if it actually applies. Maybe it's something on... No, we don't really have a Z offset here, do we? No, I'll figure that out later. I don't really care if it flickers for now. The fact that the green circle is flickering is because it's right on the ground, and it's getting Z fighting as a result. So the GPU doesn't know when to see the ground as the top or whether the circle needs to be on top. But there's ways to offset that, but either I need to move it slightly up or I need to do something in the shader, but I don't really want to deal with that right now. All right, so we forgot to turn our time back to 0. There we go. That was probably our problem. All right, let's see if it works now. All right, so now we can see every second we are changing that. So, and again, I think if we're standing still, that should be much less than when we're walking. Okay, that's really interesting. Why is it hovering above that slightly? And why does it keep flipping our... I think our rotation calculation is probably... No, we're not rotating anything. So why would it get this rotated? That makes no sense. Hey JD, how you going? All right, so well, one way we could do that is I'm just going to go. Oh, why did it not like that? Huh, weird. I just want this one to be somewhat forward, and I'm gonna make that unique because I just want to have that also got a slightly different color, so we can tell them apart. There we go. Just want to see if we can actually see our target messing up or if it's something with our I key messing up. Still don't get why it's... There we go. It's... Yeah, it's definitely our IK messing up somehow, but I don't get why. Is that something to do with the fact that we have got it in global space? Probably. I think that's most likely it. It's because we're... Why are we not rotating that properly? All right. Let's just do that on one of these. Box. So way to big box. Okay, I'm just going to move that up a bit and a bit forward. I'm only going to do it on the left foot. That's enough for debugging stuff. Ah, so I get to motivate you. All right, that's always good. It's still going good, still going good. At what point does it decide to mess up? I bet you that now it doesn't match up. Oh, there we go. All right, so I think that might have something to do with the way we do our lerp. That it doesn't like that. I bet you if we just do target, we just do that, I bet you that will work. So I'm guessing that this is a precision thing, and there's a way that we can deal with that. Not actually. I'm actually quite happy for that to just rotate. Still don't know why. Why is it hanging above that for a little while? Because the thing is, it's from, oh, that's kind of nice. This needs to work differently, though. I think when we go sideways, we need a different stride. Still don't know. Factor is divided by step time, so that should go from 0 to 1. And lerp should be going from 0 to 1. So why does it catch up so quickly? I don't know. Is that just an effect because it's because our target keeps changing and therefore it catches up too quick? And we actually need to calculate how far ahead we are to where we're going to go. Maybe that should be the case. Yeah, we could do that. I'm guessing. Yeah, we could do that. So if we calculate this first, then here we could actually send our time through. This actually needs to be the other way around. So this actually needs to become step time minus time. So at the beginning it's step time and then it slowly gets back to 0. So here we're going to say time left float. And this is just going to be time left, no 0.5. Okay. And that should mean that we actually, if we're nicely walking on the ground, we see that our, yeah, that's much better. So now we see that we get our target where we actually want to go, and we're stepping forward with our foot. That's pretty decent. Obviously, when we're turning, we do adjust where we're going to land with our foot. If we don't, then we don't. Now, because we are actually got our step time quite far for this speed. All right, so eventually we're going to want to fluctuate that. So let's say that we take half a second for each step. Is that going to mess up because of this again? Of course it does. Is this going to be okay? Yes. All right. Okay, that did not work. Why not? We still have our debug thing. My debug label. Let's go and label 3D debug. Okay. Debug text is time 3F. Time. All right, let's see what that does. Sorry. Change type. 2D, please. Just label? Yes. Didn't want that as a 3D label. I want that as a 2D label. There we go. It's going to 5, and then it stops. That's because I was hard coding this to 1. Was I dumb enough to do that? Probably was, yes. Here we go. All right. Pretty cool. Where is our thing? Oh, there you are. Dun, 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 dun. Okay. Oh, yeah. We don't have our raycast logic anymore. So let's steal that from here. Oops. Make target transfer. So. So I'm actually going to make that in a separate function and say func test target raycast target transform 3D. Make that transform. There we go. And that's going to return a transform 3D. All right, so we need to set that up in a minute, and then we're just going to go return our thing. So we just need array offset. How did we define that here? Walk. I'm going to call that feet array offset in this one. Okay. Boom, boom. All right. There we go. No, still not doing what it's supposed to. Oh, because I'm not calling it. I still need to call my target basis. Okay. So target transform is targets. The reason I've done it this way is that first of all, it's nicely split out in logic, but also because we only have it in global space in here, and for our raycast, we need it in global space. Here, let's get our target transform. Check if there is something our way. All right. Dun, 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 dun. All right. So here we have our problem with our Z fighting. So what I'm going to do here, position dot y plus is 0.01, just as a helper. Do the same here. Okay, so we saw that it went on top, but then we stopped because we no longer have that. Okay, cool. The other thing that I wonder about is we're right now doing on actual velocity, but should I be doing this based on the desired velocity? one easy fix is for wherever that character body 2. All right, so move left and right. We're actually going to make that half so that we don't get such big sideways steps. There we go. One thing that we really want to do is limit our turning ability based on where our feet are, but I think also something that we could do is that we could make our walking offset, our feet offset, change depending on how fast we're going. So if we're standing still, we put our feet apart. When we're walking, we move our feet close together, because you actually, when you're walking, you're going to put your feet more closely. So, and I wonder if we should do that as a curve. I think we should do that for both. So our foot offset we could do as a curve based on speed. But also our step time we could do as a function on velocity. But then we want to calculate our feet step time at the start of our movement. All right, I'm going to keep our step time as is, but I'm going to change or add a curve here as an extra thing. Bar feet step curve. Is that a curve or 2D curve? I can't remember. Let's see. Is curve what I'm after, or is it new curve? What is, yeah, this is what I'm after. So on one input, we're going to get an output. Now we've got a minimum domain and a minimum value. So our domain is going to be our speed. So let's say that we're going to go through a speed from 0 to 10. And here we're going in time. So let's say, hey DK, how you going? Let's set that to 5 for now. Oh, come on, make that a bit bigger. All right, and I actually do not want that to go all the way to 0. Sorry, it's not for you. This one, I do not want that to go all the way to 0. We always need some time so that we keep our function going. So we end there. We start there. There we go. Now the question is, do we want a curve like this? That's something that we just need to experiment with and see what works. So now we're going to go and get our step time as an input of our velocity, and we're going to sample that at the start. So I'm actually going to go and do this, and instead I'm going to say here var step time float is 0.01. That's what we're going to start with, which means that everywhere that we now have this and this and this and this, and here we're going to go and calculate our new step time as fit step curve dot okay, why am I not seeing the function that I want? I just want to get a get value. So I think it's like a get bake point or something. That's some difference. No. Oh, here, sample baked. What's the difference between sample and sample baked? Here's the y value for the point that it would exist at point x offset. There's the y value. Offset on the curve. I think that's really what we want. So dot bake, and here we want to have linear velocity dot length. Actually, let's go and calculate that. Our velocity is that. Okay. And to do at angular velocity. So if we're turning, we want to make sure that we adjust that as well. So now you see that's, you know, that's the problem because I'm not doing anything with my angular velocity. But now we have that as a curve. Now we can already see that we've made our curve way too big. I think our maximum of 5 seconds is probably way overkill. I think we're gonna limit this as a domain to 2. Oh, let's go and move this down. Can I now make my domain 2? Yes, I can. Means I can make this, that. Okay, let's see what that does. Again, the turning is not going. So now we've got small little steps. And that's already way too big. But the idea works. Okay, so what if I just make this straight as possible? Make that a linear, almost a linear function. Way overdone. How fast were we running? We went to 5. See, here's already the movement. So why do I do that? That should already be like here. Yeah, JD, it's definitely not the sort of movement that we would be after. I think I might just get the one. But why am I not allowed to do that? Do I really have to make sure that this is in range? And I actually want to limit that to 5. Oh, I'm not even allowed to do that, really? 5. No. And all right. I really don't want this to be linear, but it's just to test it. Oh, look at that. We actually have some. Oh, because my minimum is now something much more sensible. That is still way over the top. It's hilarious though. So, okay, so do I really need to do it kind of like this? Okay. I think that even going to, okay, let's go and make this 0.5 so that we can actually see the curve. But I actually want it to be the other way around. So 0.1. There we go. Oops, don't want that. The other thing that I wanted to do is we have the default. Actually, that doesn't really matter. That our default value is nice and little because it's only going to last for a hundredth of a second, and then it's going to start whatever animation it should do. Yeah, you can do so many cool things with curves, but it's really one of those things where I should really expose, excuse me, I should really expose the curve here so that we can more easily adjust it. I think also we should be making the height different, because that's also part of our thing that's not really working very well. I'm going to make this much sharper so it gets to a second way earlier. All right. Okay. Because this is still too small, and that is decent for a running animation, but that is still too small. So it really makes me wonder, should this be... I just put another one of these in, bring that really close to here. Oops. Hold on. Still don't have, because that's weird, because that's on 2, I think. It almost seems that we actually need to go a bit higher. Oops. And then it actually slows down a bit. Yeah, I think so. Let's move this to 2. I think that's the speed at which we're running. Let's move that to the max. Let's see what that turns it into. It also reminds me we haven't checked this, so that's still good. Still think that the walking is too small. And that still feels too big. So I might actually move that down, and I might actually go turn that up. Put you up there. Yeah. Stop creating things like that so easily, dude. All right. And I want this to be a sharper one as well. Let's see what that looks like. Okay, so now we're making slightly bigger steps. Very nice. Obviously, we're not moving the upper body at all, so it does look like a very unnatural run, and we're not lifting our foot yet. So let's do our lifting of our foot first. I think that's probably a good idea. Now, what was the other one that I was thinking about turning into a curve? My foot offset. I think we want to make that a curve as well. Make that a foot offset curve. Need to give this all descriptions eventually as well. All right, so we're going to create a new curve there. Same thing. We're going to have a domain going from 0 to 5. And in this case, let's go there. So here we're going to start at 0.25, nicely wide apart. Yeah, I really enjoy submodules. Submodules are a bit of a learning curve to really learn how to make it work for you, because it is very easy to get mixed up what commit of your submodule you're working against. But if you're diligent with it, I really like it. So for instance, Extra Tools 2, I've changed it so that you're actually using submodules there, because I just like it a lot more. All right, so here we want to get that really close. Here we want to get to fairly close as well. There we go. It's a good one. Do we want to do that a bit more like that? Oops. Always when I just want to deselect something and it just goes and creates a new one. Okay, so that's the feet offset curve. So we're gonna now do a foot offset for feet. No, I'm gonna call that foot offset. Oops. Foot offset float is 0.25. Let's just do it on our standard thing. All right, let's just comment this out so that we get some errors where we need them. There we go. There we go. So foot offsets, and now on our finish logic here, this one is going to be is feet offsets curve sample baked velocity. There we go. Oh, not bake, baked. Oh yeah, the color palettes are pretty cool. All right, so we now have a slightly bigger sideways stance. But now when we walk, they go closer together. And when we run, our feet gets even closer together. Okay. Now actually, when we are here, might even want to get them way closer. Might even go to get that to 0. So when we're running, we're really putting our feet one in front of the other. Even a bit more like that. All right, let's see what that does. I still think that is too far apart when we're walking. Okay. Want to add my angular velocity in here as well, just to do something more of that. So we need to do a nice little factor for that. Well, I only really care about the y velocity. So let's say that we say velocity dot angular. The plus is absolute p angular dot y. So whatever in the y direction we're turning, we're adding to our velocity then. That's a really crude way of doing it. Oh, that is way too much. Let's take 1/10 of that. Okay. Don't need you anymore. Don't need you anymore. Okay, I'm still not really happy about the curve here. Is that because I'm doing something bad here? No. I'm just gonna go and put that really far down. Because it just doesn't look like our step is going really close when we're walking. I'm expecting our targets to be right next to each other. Okay, let's just for fun see if we put this all the way on 0. At this point in time, I'm expecting that when we walk, I'm close. They're not exactly 0. It doesn't really make a whole lot of sense. It's as if this curve isn't doing what it should be doing. Yeah, we've got a really low value. So feet offset curve. This is the feet offset curve. Foot offset. Makes no sense. All right, I'm going to do something dumb. And I'm going to comment this out for now, which means that we're no longer walking. So here we can see that it... Okay, we don't care about time anymore. We now want our offsets. The only thing that I care about is our X offsets. So let's go to 0.12, not to 0. Why not? Are we adding something to it? Okay, what if I just do this? Let's see if our input is correct, at least. Yeah, it's going to 1.27. So, ¿qué pasa? Am I wrong about our velocity? Maybe I'm wrong about our velocity. Because our velocity is 1, not 2. And that's also what we've got wrong with this guy. We actually need to go to here. And now we can probably do that a bit lower. So let's do this one as well. Let's go all the way to 1. There we go. Okay. No. So got that. And now they're too close together. That makes sense for running, but not for walking, unless we're a lady. Which obviously is something that we can now control. So we're going to want to put this slightly higher, maybe something like this. That's better. Okay. Starting to get there. All right. Oh, are we having network issues? It might be that my son is playing games online as well and taking up all my my bandwidth. Although, according to YouTube, my stream health is good. It's not giving me any complaints about speed. And I'm not reading any dropped frames. So I don't know. I don't know. Yeah, let me know if the stream's gone back live or if there's something weird happening. Well, it could be on your side, DK. All right, so this is now working. That is now working, but I think that I probably want to take this down a bit. Alrighty, let's see what we look like now. Okay. I think it's time that we do something about us lifting our feet when we are walking. Okay. Class libraries in Godot like in .NET. I'm not quite sure what you mean with that, Zimcon. We do have a plugin structure in Godot, so that you can bundle code up into a plugin and distribute that. So yeah, I'm not sure. Right, where are we with this? Okay, we no longer need you. I'm gonna want to put these together. Do want to put some helpers here. Let's say duration of a step as a function of velocity. And then here, distance of feet as a function of velocity. Okay. So I realize we haven't. So we're sideways stepping. Because that's a thing where I really wanted to make more use of this, because so I actually wanted this to be more like so. So that here we can go with a sideways step, which was half speed. We wanted to bring this down quite a bit more. All right. So now when we watch sideways, oh, I've now increased the time for sideways. That doesn't make sense. All right, let's do that a bit more. Okay. Let's put that in our debug info as well and say step time 0.3 f. Let's go and put that in there. See what that becomes. Okay. So that's 0.6. That's 0.4. That's quite a lot more than I was expecting. Velocity is 1. Velocity is 1. That doesn't make any sense. Why is my sideways velocity 1? Character body 2. Oh, maybe that is still wrong here. Yeah, there we go. Oh. Okay. Go do that. Right. Okay, so that's still good. That's a little low. It's funny. Yeah, a little bit low. That's because we adjusted this way too much downwards because I thought it wasn't working. Maybe even take that out again. Because here, yeah, that's pretty perfect. All right, let's do feet height. So our feet height is actually going to be a function of time. Although maybe even, again, the height is going to be a difference of speed. So we gotta get two factors here. We have the pattern that we make, and then the top is going to be a factor of our velocity. Okay. That's kind of what we're doing in extra tools, where you add little building blocks. But with movement code, it does get kind of difficult because when you start splitting out the movement into different little bits of logic, you don't really get, you can't really do move and slide for every single little bit of movement. Things get really crappy that way. But one thing that you could do is that you say, well, my physics process on my character body is just the move and slide logic and maybe the gravity logic, but you instead of handling this as fixed logic, is here you call all the child nodes of your character body of a specific type. So whatever type you have as a base class for your what you call it, for your library, and each one manipulates velocity in a certain way, and then your end velocity is what you bring into here to actually do your move and slide to apply that movement. That's one way that you could do it. All right. And then obviously the order in which those nodes are present handles how to do this. It's something that Malcolm and I are actually thinking about doing for Extra Tools 2, because the way that we're currently doing it for Extra Tools 1 is very convoluted, and we really want to simplify it in that way. But we haven't had the time to finish that logic yet. We've got a basic thing together, but we're not happy with it yet. Where were we? Oh yeah, let's first do a curve for the progression over time. So so we're going to use our factor, so the one that we calculate here, which is time over our step time. So that's a thing that goes from 0 to 1. But we're also going to do a 0 to 1 in height, but then our actual height gets multiplied by whatever height we get based on velocity. So there's going to be two factors here, two curves. So our first curve is actually going to be our height curve. Put that actually between these two. Let's bar feet step heights. This is going to be curve. Okay, so that's there. So I actually want to go and make that small, create a new curve for here. That's going to go from 1 to 1. Boink, boink. So let's just start by doing it somewhat like this. So as we move our foot forward, this is actually kind of the curve that we're going to make through the air of our foot, right? So we're going to have that. Now let's just say a bar foot max height So this one we also want an input curve for, but we're just going to fix it to 0.1. So now when we're standing still, we're going to go and step up and down like we're marching in place. Obviously, that's not how we want to keep it, but that's what we're going to start with for now. Now, the other thing, of course, is that actually needs to be added to the logic here, because oh yeah, we're just gonna add that here. So this is gonna be food transform dot origin dot y plus is that. And this is going to be interesting because right now we're always assuming that up is up. Sorry, this is sample baked as a factor input times food max height. There we go. So we might have to reorient this. Actually, that should be fairly easy. That's a good one. So we actually want to do this as a vector 3 0.0 0.0. So that's a thing pointing up. We're actually going to take our transform just in case, and again, our base isn't working properly or isn't vertically aligned, because again, we're doing this in global space, but we could be on a tilted platform where we're actually angling our character body, and we want to make sure that we're actually working on the right up. So I'm going to orient that. So here, add our step heights, burp, our movements. We already fixed the problem that we had here, so let's put that back in and see if that makes a difference. Ooh, breakpoint. Bakes. No, baked. There's a D in there. There we go. Like I said, we're marching in place. Okay. Maybe a little bit too. Not too bad. Oops, that was a jump. I think one of our problems is that our magnet isn't really in the right spot yet. Problem is that we're not putting our foot forward enough for where our magnet is. That could be a factor of our step time now that we got going up around. Okay, so we need to make sure that our heights, let's do our height first, so that our height as a factor of velocity is in there. Exports. Can't type. Var feet heights. Curve. Yeah. Our feet maximum as a factor of velocity. All right, there we go. Boink. So we're thinking that we're going to move this a little bit more back. And I want this fall off to be much sharper like that. All right, let's do that. And then here, a new curve. And here again, we go to a domain from 0 to 5. That can actually be 0, that's fine. So we're going to go do that. We're going to go do that. And then this one, let's do it like this. I don't know. Let's just see how that goes. I'm not quite sure. Do we actually want, no, we don't want it that high, do we? It's dumb. Hold on. There we go. This guy should not be even be, because we're already at 0.1 for our testing. I'm thinking that this should even be less than that. It should almost go to there. 0.2. Some of this, I don't know. So that becomes now over here. Oh. But max height is that, and then again, sample baked velocity. All right. So now when we're standing still, we see that we are lifting a little bit up when we're stepping around, which is kind of nice. Then when we're walking, oh, why is that suddenly? Okay, how do we mess that up? Well, did we mess that up by taking that lerp out? Really? Let's see if that was indeed. So we just can't lerp to our target. That's so weird. Okay, so I need to figure that one out later. But we do have that. And again, this looks dumb because we haven't, we're not moving our hips yet. We're not actually moving our body up and down. That's something that we still need to do. So the run animation is crap. And for the run animation, I really need to slow it down so that we can actually properly see what it's doing. But I think the walk animation is getting closer to what we want it to be. And again, I'm not bobbing the player up and down yet. That's actually also one of the things that we want to work on. Yeah, this ding ding ding. This just looks so dumb. Okay, so the next thing that I really want to work on is actually the foot rotation that we're doing. Yeah, it's getting closer to what we really want. All right. I want to put this over here as well, so I have both of those available. Just top. And I actually want to do the global. I want to put that there so that we can actually add some logic in between here while we still have everything in local space. And I want to do a rotation curve as well over time. And we're going to do the rotation actually over 2. So 0 to 1 for the foot that's in the air and 1 to 2 for the foot that's on the ground. On ground foots. Yeah. What is this? Yeah, that's fine. It's because we haven't really done anything with that. That means I also want to have that there. Also want to have that there. And now we're going to do the... Oh, hold on. Why am I not on group? This is off. Or actually, this is going to be in air foots. Why do I always keep typing group when I want to type in ground? Something in my brain that's not working properly. So now I want to do P on ground foots is a node 3D. There we go. So we can also deal with that one. Cool. All right. Offset curve, and then it's going to be export bar. Repeat rotation curve. This again, we need to do in 2 things. Is one is have it as a factor, and the other have it as a maximum based on but let's do the one first. Again, we're going to do here var foot var foot max rotation float deck to red. Let's say a maximum of 10 degrees either way. All right. All right, so new curve. This one is going to go from 0 to 2. And this one's going to go from -1 to 1. Now we really have to think that through. And how we're going to do that. So I definitely want to go and put one over there. Make sure that that is actually 0. Oh, is it 1, 0? Yeah. Cool. Now we need to have one at the beginning and one at the end. That's all 0, 0. That's 2, 0, 0. Okay, cool. So those are our control points. So these are probably going to be somewhat higher. All right, so all the way there, and eventually we want this Foot. So at the, oh, why does it not rotate? Makes no sense. Oh, our IKs are not working once again. Let's reopen it. Okay, what about now? All right, so that is going to be towards -1, and then actually our default value here of 10, we're actually going to make that 30. Now, back to our avatar. So I'm going to do that. And we're going to go here to maximum. And then we're going to start with that as well. So we're going to have rotate it like that. And all the way while we go forward, we should slowly be moving this. To the other side. But then at the end, when we hit the floor, it needs to be flat again. Okay. And while we're on the floor, we're going to flat, but then at the end, we're going to start rotating it. And at that point in time, because it's still on the floor, it's not really going to show much, but we'll see. Okay. All right. So with that, we need to do here rotate our quotes bar rotation factor is that sample baked factor. So this is for the foot that is in the air. All right. Now we're going to say pay. No, we're going to go and say, oh, but we don't have that one. I'm actually going to leave that as a to-do. So rotate. Oh, I think I know a way to do that. That's all right. So here it becomes fairly simple because our target transform bases. Let me think. We didn't do a rotation yet in here. And we wanted to do our oh, that's a target. Hold on, wait. Yeah, we actually can't do that here. Oh, that's funky. We actually need to do that here, just like we have our height added here. Rotate our foot. So in this case, we get a rotated factor, which means that we want a rotation basis. Our rotation basis is basis vector 3 left. Might be right, but we'll see. Rotation factor times feet max. Max rotation. Okay, so that's for our left foot. Oh. No, that's actually going to be transform.basis, rotation basis, in air foot.transform.basis. All right. And second time. Now we're going to add 1. And now we're going to say on ground foot is that rotation basis times its own basis. That's going to be a problem. Because we need the original transfer for that. Dang it. So we are going to have to store that here. Okay, so what we're going to do for that is make a var on ground transform. Okay. Here's my ready function. That is going to be our right foot, and that means that we can do this. Cool. Now what we can do is target. I actually want to do this last because it's all part of our debug stuff. So let's do that like this. And now we can add that rotation to that. That's actually a good one because now yeah, that's actually good because we've got our So we actually add our height here. Yeah, that's all right. Because we're getting it on our transform. That's actually before we do any rotation. And of course, at the end, we know that we're going to be on the ground. So that transform is fine. Yeah, because once we do that, we know that we're always going to be on ground. So, all right. Let's see if we messed this up or not. Well, of course, we're going to do that because we haven't adjusted our rotation value yet based on our velocity. Now the question is, no, it's rotating the wrong way. No. Right. Okay, I think this should be there. that. This should also be there, like that. But I think that should actually go like this, because as we're stepping, we're going up and then like that, and then we're going back there. So let's see, up, and we're gonna go like that. No, this one does actually not have to be there. So I think that goes there, and that goes like that. Maybe that goes like this. That's good. That's good. Oops. This might actually also go a bit more like that. All right. Let's see if that makes more sense. So I have a feeling that the it's not starting in time with this one. So let's move that all the way forward. Let's see what that does. Okay, that still doesn't make any sense. Is that scale correct? Yeah. Right. Yeah, now we're actually getting that our foot lifts when we're in the last part. Okay. I think on our step curve, I actually do want this to be all the way over there. This is so funny. We're standing still. Yeah, that looks pretty good. Obviously, this is still too much. It's interesting that first step, because we're adding our velocity straight in there. Okay, why are we? Okay, we have we're applying the rotation at the wrong order. This needs to be here. Okay, now we're gonna find out that our rotation is still reversed. Okay. Yeah, that first step is a bit of a problem. Okay, so it does the right thing now. Yeah, that's all right. Yeah, this is definitely wrong, but that's all right. I still need to get back to custom shader templates. I haven't had any time to look into that. So whether I'm gonna make it before the cutoff date for 4.5, I'm not sure yet. It really doesn't like jumping yet. I'm not quite. Oh, that's because the velocity of jumping is being put in. I think we did that in the old one, that we took the jump velocity out of it. So here, apply. Come on. There we go. You know, one of the things, of course, is that we jump without any sort of thing there. It is super fun that it does that. Okay. All right. Now, one problem is that, of course, for this, we have our jump velocity in here as well, and I think I want to take that out of this even. So I might even want to say that this is going to be over here, so that it also doesn't take into account this. Although I kind of actually liked the jumping, bringing the legs together. Because this is one of the things that we now miss, right? Is that for the jump, we really want to actually bend our knees and then jump. And that's something that we eventually can do with animation. And that we actually make it dive and then up. And that's actually one of the properties that I want to put in here. So, that's a good one. How we're going to do that? Because part of, I actually want to make it more natural that it, that we actually climb up the stairs for when we are putting our foot up. So the way that I want to do that, actually, let's start working on that bit first. So I want to remove the ground collision here. So now we just have the body collision, so only our body goes there. Now watch what happens. This is going to be funny. This is going to be hilarious. So now we sink to the ground, and we're there. Now, obviously right now, because we sunk all the way to the ground, our feet completely went through. So we actually need to do, so we're raycasting actually a little bit above the foot down through the floor, and we probably need to make that higher. I think that we made that a setting here. Well, that's 0.5 meter. That's actually good enough for now. The idea that I have is that as we, no, that's probably going to have to be 1 meter. Because what I want to do is that as we're falling, if our legs, which are going to be on the ground, if they are going to move up from where our avatar bottom is, so we obviously know we're going to know them in local space, then we can sort of push our body up. So, and that also means that we're going to have like a natural spring to our character, which also means that if we jump and we land, we're going to automatically sink through our legs a little bit, because I want to actually update the velocity as a result of that. So what we're going to do right now is we're going to make sort of like a target midsection or a target height of our character, I think. So right now we already know that our character is nicely put on the ground. We've got a pivot here. So we're going to make a target height for our pivot. And that's going to be the height between our pivot and the foot that's on the ground. So I'm first going to do that before I'm gonna deal with the flapping of the well, maybe we do the flapping of the feet first. Oh no, we can't because I just removed the body. So I have to finish this first. So so what we're gonna do is, and this is something that I want to be able to control from outside. So we've got our hands, we've got our feet. We actually want to have an export group body. Okay. Okay, so this is going to become export var. Actually, I want to make that a range. I do not want to have that. I probably don't want to have that below that. And I don't want to have it, actually, 1.45 should be the highest, because at that point we're standing upright. Our character can't be bigger than that. Okay, var body shoulder height. So this should be 1.45. So that's what we're going after. So that should also now be what we have here. Okay, cool. But here I'm just going to have some fun that we're actually going to make that 1 meter. So we're going to make sure that we sink in a little bit. All right. So that means that if the difference between our pivot point and our foot that's currently on the ground, if that space becomes less than that target height, we're going to push the body back up. We're going to make it work like a spring. So we're not going to just adjust the height. We're actually going to apply a force to the body. And we're just going to do that by manipulating the velocity, because we're never overwriting the velocity. Although right now there is a bit of an issue around the velocity assuming that we're upright. So if we look here, all this code assumes that our velocity is in local space, or that we're upright. So I might actually do something around converting the velocity to a local velocity, then doing all this logic and then bringing it back to a global velocity. That's actually a nice exercise to do. So we're going to do local velocity vector 3 is this is going to be global basis dot inverse times velocity. Okay, so now we can apply. Actually, the gravity should always be the gravity should be in what you call it, in global force. So yeah, so this should always be in global. Then we convert it to local velocity. Then here, this now can be transformed. So that's no longer global transform. We're doing that on the local transform. We're doing this as local, this is local, local, local. And now we can do velocity is global basis times local velocity. Okay. And I wonder, should that be the global basis of the parent instead of me? Wonder about that, because I'm sort of wondering if we're going to double apply it now, because we're already doing this transform based on that. That's a hard one. I'm actually thinking that this should no longer be with transfer. So we're doing it purely on X and Y. And here as well, this is just going to be local velocity Y. We're doing jump velocity. So now if we're on a slope, we're actually going to jump in the direction of the slope. All goes well. Reinforcement learning. What's reinforcement learning? And then we go back to that. So we're actually applying our basis here. So that really makes sense. Yeah, now it makes sense. So we could do all our calculations here in local space, and here we go back to that. All right. So, all right, let me think. Now the other thing is that obviously when we're falling, we can't do we actually need to check whether our foot is actually on the ground. And that's going to be tricky. How do we do that? Oh, we can do that by the fact that whenever our target is less than 1.45, wait, if we ever get more than 0.45, we know that we're off the ground. So that is something that we know from this. Yeah, so we purely have it that, okay, if that size is smaller. All right, cool. So where are we going to do this? I think we just should do this in our process itself. So we've got our movement logic working. That's cool. So here, check if we need to adjust our do we already have our player body here? No, we don't. So, parents is get parents. There we go. Wow, parents and parents is character body 3D. So that becomes not character body 3D. No. This is wow parent. No, it becomes and parent is not, and we do parents is parent.get parents. Okay, not parents, return. So we don't have a character body as a parent. Go. All right, let's see. You'll also need some variables for if a foot is on ground or not, I think. This is not always on ground, only at certain times in the animation. Well, that's what we're already taking care of in the logic here, right? So we're already doing a raycast check to see if our target is on ground, and we're putting our foot there. If we never hit something, we're just going to have our feet floating, and that's fine because then we're never going to get that 1.45 distance between those. So let me think. Yeah, because that is the difference between the pivot heights and that. So whenever it's smaller than that, we're not going to give any upwards force. And the other thing is, of course, that also depending on how high it is, we might actually make that stronger. So if we're in the air and our feet are just dangling, then we're not going to be pushing upwards. Only if we sort of sink in, we start pushing. And that means that we're not going to be completely our height of 145, but that's fine. So we want to do this in local space. And for this, we need to get our on ground. So we might actually go and do that here. Oh, actually, we have that already as a transform here, don't we? We have our on ground transform. Perfect. So what we're now going to do, we only care about our position. So local on ground, on ground position. That's a mouthful. Vector 3. That's going to be based on that origin, but we're going to put that into all right. So that's now in local space. So now what we want to do is, let me think. We want this to be at a certain height. So for that, we get this position minus, yeah, go away. Yeah. So actually we even, okay, so let's actually do, we're just going to go let foot height. So I actually only want the dot y from this. Target height, and that's now no longer becoming, that's now becoming a float. Pivot dot position dot y minus body shoulder height. So that's where we want it to be. And now we need the difference. So how much difference between that and that there is. If it's bigger, then we're happy. If it gets smaller, then we want to apply a force. Let's see, what does that mean? So let's say that yeah, so we want to do factor of force is foot height minus target height. We want to do, we never want to go in negative. And this is something that the higher it becomes, the more we want to push up. Hello, Will. Low wheels. Low wheels. I don't know. How do you pronounce your nickname? It sounds like a Welsh last name or something. Probably got that completely wrong, but all right. So this is a difference in meters. I think we're just gonna do an arbitrary factor to that and see what works. So what I now want to do is I want to say, oh, I also need to go and convert that into a force vector. So force vector is going to be vector 3 0.0 0.0 because we want to apply that force in the top, but also we need to put that in that. So now we can do parent dot velocity plus is force vector. Let's just do times delta, see how good or bad or ugly. It could still be that it falls apart, or it could be that it keeps jumping up. We shall see. All right, that's just full there. Yeah, so that definitely is not enough. Let's give it a lot of force and see if we're even in the right ball. No, we're not in the right ballpark. All right, so I'm going to put a breakpoint there. All right, so foot height. That sounds about right because our feet are pretty much on the ground right now. Target height. That's right, 0.45 because, no, that's actually not right. Okay, body shoulder out. Oh, what? No, that is right. That's a target height, so we want it to be there. And now foot height minus target height. So our force vector will now be, okay, so I think that is the wrong way around. Foot height, 0 minus target height. That should be minus 45. Okay, that doesn't make sense. Wait. I am actually going to go and put that over here. All right. A low whale, like the deep in sea. Okay. That's cool. All right, so target height. Force vector is null. Oh, haha. Why is... Oh, that makes no sense. That. Why? Oh, because I haven't stepped over yet. Okay. Force vector, that's why. So minus 0. How can that be? Oh, because I need to get the maximum value. That's why. All right, so still not working properly. That. Okay, and I might actually just want to do if force bigger than 0.0, boink, oops, boink, boink, and I actually want to do force times is delta times 100, and there we go. What am I doing here? I forgot a bracket. There we go. Okay. Okay, so now we've got our max. Yeah, it's kind of interesting that we are waiting for that point to do something. Okay. Got a tiny bit of force. So maybe the times 100 is not enough. We don't know what the parent velocity is yet, so. Point. All right, so 1,000. Let's go crazy. All right. Okay, we managed to fall through the ground. Okay, is that our force is still not enough? Or is that because it's now too much? Okay, so not quite what we want. Hmm. Okay, one thing that I want to know for sure is do I have something stupid in here maybe? Actually I want to go, if not on floor, then we add some gravity. All right, cool. So that makes us fall, but once we are on floor, we're no longer adding anything to our velocity. And of course, if we hit the ground, we stop, and that makes velocity go 0. Okay. And here, if we are on floor, oh, we never, wait, it's on floor. Okay, let's go. Yeah, that's a problem. Is that I always have to keep remember putting it back this way. I keep forgetting. It's the downside of having a larger screen. So look at that. We are just automatically jumping. Yay! How is it? How is it even doing that? That makes no sense. I don't get it. That makes no sense at all. What am I missing here? I'm missing something obvious. So we're bringing this into local space. Let's just first, because that might be part of my problem. Oh, huh? Oh yeah. Oh, that needs to have 0, 0, 1. Okay. Yep. Yep. So now we keep flying up. So that's because we have our this one way too much. Let's go back to normal value for that. So yeah, so now pushes back up and it sort of oscillates. That's probably because we don't have a damp function in here. Mm-hmm. Why is my keyboard inputs no longer working? None of my keyboard's inputs are working anymore. Is that because of what I'm doing here? Oh, I'm an idiot. Oh, I'm a dumb idiot. Of course, because the problem, of course, is we are now doing the is on floor purely based on whether our collision shape is hitting the floor. And we're therefore only doing our inputs when we're doing that. So we're actually going to have to do our is on floor check also based on our avatar. And we can do that by yeah. So we need to do that by checking on here. What is it? So we're doing our target raycast here. Transform. Yeah, so we need to, when we do our raycast here, we figure out whether this is on floor, and then obviously when we're setting our on floor transform, we also need to set that foot is actually on the floor. And then we can get whether our avatar is actually on the floor. So what we're going to do is we're going to do that for is on floor. Oh, I'm going to assume that to be true. Bunk is on floor. Is on floor. Returns whether our avatar feet are in on the ground. And now we need to go and set that region. Look. Functions. There we go. All right. And in this case, actually, in this case, what I really want to do is I want to have that actually working from our actual feet, not from our target. So if we look at here, I'm actually going to need to go and add in, where are we going? A child node, no, bone, what's that thing called again? Bone attachment. Okay, left foot. So this one is going to be left foot, and now we're going to go and do a ray cast here. That actually means that we're not going to deal with a on the floor variable. We're actually going to check our ray cast here in a minute. So we only care about the foot that is actually on the ground right now. Which actually reminds me that we don't really have any protection for our feet going through something yet. We can actually step through a wall until our body stops moving, but yeah, well, we'll deal with that eventually. So left foot. Why is that not actually on the left foot? I'm guessing that that's again a problem because I need to reload this. Left foot. Yeah, now it's good. Raycast. So this is so dumb that that is actually not even straight. Let's see. Are we really on? That's on the toe. That's actually kind of good. I kind of like that position. Interestingly, that it's not nicely horizontal, but for what we need to do, that is fine. So now we're going to go and look at our raycast. I think that is then minus 0.2. So we're just going to, we can actually move that a bit up. So we're going to just do it like that. So as long as that raycast hits something, we are going to be good. Maybe we should let it be okay if it thinks that that's close enough to the ground. Yeah, I like that. All right, so let's duplicate that and call that right foot. And we're now going to move that to the right foot. There we go. So we have two nice raycasts going down. Alrighty. Should be good enough for what we want to do. Are my raycasts automatically enabled? Can't remember. Yep. Exclude parent. So that's fine. All right. So there we go. right foot raycast. Okay. Left foot, right foot. Cool. Okay, so if our left foot is moving, we get return right foot raycast, but is colliding. Else left foot raycast is colliding. We don't need to check them both because only one is on the ground, and we know which one is on the ground. And I think the only problem is that once we start moving our foot, that's all right, actually. I'll deal with that. That's fine. Sort of wondering if I should negate the rotation that we're doing. And I'm happy with that. We could improve that eventually, but for now, so we're still going to keep this as a backup if we really fall through everything. But here we're simply going to say, where are we? This is going to be on there. So that is avatar 2 is on, what do we call you? On the floor. All right, see how that makes a difference. All right. Okay, so we're definitely overdoing it now on our avatar jumping logic. So, let's do it like that. Okay, now we have to little bit of trial and error here. Okay, we definitely need a dampening in here. The nice thing, of course, is no, it's over here. So, got to jump at a velocity. Else, we're going to go and do that, but we're also going to go and damp our y velocity. Oh, here we're going to say local velocity dot y is not times this, okay? 1 minus damp times. So now I just need to put a y damp in there. It's not really doing anything. Maybe I actually need to put that a lot higher, seeing that we're putting delta in there. Okay. I think we need a much higher damp for that. 10. Okay. Oh. That's the thing that I really wanted to see happen. That when we walk up the stairs, it automatically goes up. There we go. I need to fix this. Okay, I think now our jump factor needs to be a bit more because we're having our own damp in the way. Although part of me also sort of goes like, all right, if I now put this to 1, okay, that didn't save, did it? Okay, what's going on here? That should definitely be doing something. All right. Okay, that is not doing something. We're calculating something wrong. So foot height is 0 because we're on the ground. Target height is 0.45. So this should actually be the other way around. Oh, hold on. So in this case, we should also say that we're not on the ground. Because even though our feet might be touching the ground, we haven't actually gotten our height correctly. So in this case, we might actually want to override that. This is actually the wrong way around, so let's go like this. Where's the other way around? No, it's the other way around. Problem is that we're not seeing this as okay. Ignore on ground. False. Here we're going to say if return false. And what I want to do here now is false. Okay, let's see if that does what I think it does. Oh, and now we sync all the way through. And again, I think at this point in time, we just don't have enough space. So let's go and be a bit more conservative and put it on 0.2. No, still falling down through the ground. And I think the problem here is that we're falling far enough through the ground that our raycast to detect whether our feet can be on the ground is no longer working. Because we can see that our circles disappear. So our circles should actually still be there. And they might be there. That's kind of funny. But yeah, I think at this point in time, So I'm starting to wonder, should I actually do a force? Because that's the other potential that I could do, is that we actually don't care about that. Oh, sorry. Don't care about that, I mean. But then I move this here. So we always do the gravity, but we're always going to negate the gravity. Okay, now the other thing that I really want to do now is double check if our raycast is actually configured properly. So that's 0.5. Is that enough? I thought I made that higher. Yeah, I thought I made it higher, but it didn't save. Is that good here? Yeah, that's good here. So that's part of it as well. But the other thing is, what I might want to do here, I'm actually going to go move that over here. And I'm going to say here, if target height's bigger. Oh, what? Okay, so if this is smaller than that, now if this is bigger than that, now I'm going to go and ignore this. And instead, I'm just going to go and make that a fixed value. See what happens now. Oh. For some reason we're in the floor in here again. But why? Okay, that just means that because we're way up in the air, I should only be doing this. Huh. No, it's I need to do the is on ground logic differently. So I'm actually gonna return this to is on ground. True. Cool. Now what we're gonna do is we're just gonna return is on ground here. Now we're gonna go and remove this. What do you mean is on ground? Oh, underscore is on ground. Now we're going to go over here. All right. We're going to put that, oops, put it over here. This is going to be is on ground is that. And the same here. Okay. So now we're going to say if is on ground and that. So if the feet are actually on the ground and we have that, then we apply our force. else we're going to say is on ground is false. So we're going to say that, you know, even though our foot is on the ground, but because it is not, because we don't have our target height, we actually want to condense. We still want to apply gravity there. And I think at this point in time, I actually am happy to do that here, because now we're still going to do gravity until we're the right size. Okay, so what happens now? So now we are again jumping. Does look cool. But that might now be because I just want to have a fixed force here. Okay, that's kind of looking what I wanted. Okay, that's going a little bit crazy. Okay, because that's one of the other things that I want to do is if I'm crouched, I should be able to jump higher than when I'm standing up. So if I now go and put this back to what it was, now we're standing normal. So there we weren't standing up quickly enough. Well, okay, let's go get rid of that movement of the legs. It's just really dumb. Let's see. So we got our linear velocity out there. Okay, we're doing that there. Doing a little bit of rotational velocity, that's fine. So let's go. For now, I'm just going to make that a function, I think. So 8 max rotation is red. Velocity times times 5. It needs to be more because 25. 0 to 30. This really should be not a curve, but I'm slightly. Okay, so now we're no longer doing that. We're not super stable at the moment, and that's because well, we're moving somewhat up and down now. But the problem is because our camera is linked to our character, and we're now actually letting our character sink into the ground a bit. We're actually moving up and down, even though it's actually our character going a little bit more bobbing around. One of the things, though, is okay, that still needs a lot of work too. And this is because now we're checking if our feet are on the ground, and obviously we're not, so we're falling down until, yeah, we definitely need to make sure that is not that far. Let's see, that was a step curve, I think. I think I want to have that way down. That was hilarious, though. I thought that was funny as. Let's go see if that's going to make more sense. Okay, so now it's kind of better. Okay, our run is 2. So I think one of the problems that we have is our velocity increases, but we're still on our short time frame step. So one of the things that I think I need to change is for here, we are doing this times time left. But I think we actually need to adjust this length based on our current. We should be calculating this not on this speed. It's almost like we really want to calculate the target once and then finish that step before we figure out what we want to change. But I don't really like that. You know, the easy solution would be to actually make that. Yeah, let's just start with that. So what we're going to be doing here is var last velocity. So that we know the velocity with which we've calculated everything. And we're going to keep that in for now. So new velocity. Actually, now we're doing var velocity. Is that plus that? I want to take the angular velocity out of this bit. Yep. We kind of don't need this because we're already rotating our body. It's still not doing what I expected to do. That makes no sense. Too weird. It's got something to do with the way that we are going to this velocity. It's like we need to make this go way down, way quicker. Let's see. It's just that first step that's going completely wrong. I think that this needs to be a bit higher now. See what that does. I'm clutching at straws now. Okay, so why is that first step going so long? It has to be because we've got that speed still. So this is definitely not the way to do it. I think the problem is that when we adjust our speed, we're not adjusting our time, because we do this every time that we finish a step, we update this. I actually want to go and put this back to velocity. I'm just going to put this back the way it was, because this didn't actually help. That's good. And then I don't need this. So our problem is that because we need this high step time when we're walking, and that needs to fall off right away, we're still in that first step, we still are taking that 3/4 of a second. But at this time, we're already speeding up our body. So the problem is it's almost like we already need to adjust our step time every frame instead of doing that only once in a while, just to get to that step time more quickly. Actually thinking that that is indeed what we need to do here. Let's go. Put that in here. Give me just a second. And it's for Angular. There we go. And now actually going to immediately let's see if that makes any more sense. We're still nicely stepping around, cool, moving, and now that's a much better transition. And again, I don't really like the step length yet. And the fact that we're not doing anything yet with the body and stuff, but that's just something that I need to adjust. Because it's like a freaking robot that it walks around like. And I'm still not completely happy with how it moves the legs forward. The other thing that I think is still a problem is I think this still actually needs to be slightly more forward. I think This needs to be... This might be why it looks like it's walking weird, but let's see. That's actually too much. So now we see that it's actually going a bit more forward. How does that work when running? Well, that's still... Here we can see that the inverse kinematics is not yet working the way that it should. But I think it's also because we're not really doing anything with the rest of the body that looks weird. But the walking is definitely a lot better. Still not completely happy with how this works. Let's see. We'll do that times 5. But here I want to do just to get a little bit more bounce in there. Let's see. So now it's not. Okay, I want that to come up a little bit quicker. Let's actually do that times 10 and then max it out on 10. Oops. Okay, we definitely want that to be much bigger. That might still be something to do with the damp. Oh, it's in here. Let's make that a little bit less overdone. Is that indeed saving? Yep, it is. Good. Okay. I actually, it's a shame that I deleted that. Oh, but we can reinstate that somewhat. Go in here. No. Avatar. We should have kept that. So, look at this. Almost good. One, and that's not going to be called step factor, but that's going to be avatar. Right, no, actually, it's not shoulder. Okay. Still setting it somewhere here. What's that looking like? I think I need that to be bigger. Layout 50. Yep. Need to do that here too. Layout 150. Here, node. Obviously, that is not correct anymore because that's on the other thing. So this is going to be on shoulder. Right. Oops. Changed. Boom. So this is going to be body shoulder height is a value. Okay, and now in our ready function, we're going to have shoulder height dot value is that. And now for here, so minimum value is going to be, let's say 1. Actually, I might want to make that even slightly less. That's fine. 45, yeah. All right, cool. Let's see how that works. Way too small. Yeah, that's kind of cool. It's a horrible way of moving when we're sneaking. You can see that sometimes the leg just goes like that. And that's all about the magnet not being in the right place. So that's definitely, that's where the IK in, you can see that how it goes outside. We need to go and tweak those magnets a bit more. So where are our magnets here? Where is that guy? It's over there. So, oh, that's definitely. Okay, let's make it 0.1. And then this one is minus 0.1. 7, 0.7, 0.35, 0.35. Okay. Still having some problems sometimes when it steps too far forward. I think it's going past the magnet, so we really need to adjust the magnet position depending on so also what you can see is that because we've got the stands out now, but the magnets are still in, we have that it's he's getting his legs inwards a little bit. But actually, just to visualize that a little bit better, let's go and put a mesh instance here. Test sphere, not so big. There we go. Let's see if we can see what's happening with those. So, oh, they're not really positioned right. We can see that we're moving past the magnet sometimes, and that's why it's having problems with those. Okay, so Is that because I did something for the set? No. Okay, so this one is actually, made the same mistake. Okay, so I'm thinking that we need to go and reposition those magnets. Now, the thing, of course, is I'm actually going to go and always run this. Actually, export var only in editor. Boom, that's false. Oh, times. Not the engineers. Let me turn it off. Okay, cool. So now it should run even in runtime. Normally, obviously, in code, you would just adjust the magnet here, but I'm going to adjust the actual magnet node so that we can see what is happening. And I think the thing that we're going to be doing okay, so how high does that sound? So I'm going to use our target for where our magnets should be. We might actually do that over here. We're going to say let's make some unready vars again, just to make it easy for us. Ready var left boot magnets. No 3D is there we go. Right foot magnets. There we go. All right, and then over here. Left foot magnets. Dot global, no, not global position. Just position. That's all. That's in relation to the food IK. Sucks a little bit. Because I need to adjust it in local space. Okay, so we're gonna do that in a couple of steps. So that's gonna become global. Position is magnets position. Okay, var magnets. Huh. I'm probably overthinking this, but I'm getting tired. It's almost 1 a.m. here. So this is getting a little crazy. So here we want to start with our left foot target. global position, and we're going to go and take our global transform. Probably should really cache this because I'm using that quite a few times. That food goal position. Now I've got that locally. Then now what I want to do is magnet position plus is vector 3. I want that to go up by half and forward by half, just as a helper. Now, okay. Let's just have a look at how that looks. That looks really wrong because I'm moving it the wrong direction. Okay, I'm guessing that we just need to do this. All right, so all right, let's do that on the other one as well. That's now right foot, and that is right foot. Okay. Yeah, that looks pretty cool. That actually looks a little heaps better. That actually looks like a pretty decent crouch walk. Okay, now let's go on normal heights. That's decent. What about running? Well, running still looks a little bit weird. But I think it's also because we're not leaning forward, not leading into our running direction, and we're not doing anything with our hips. That's probably also something that we need to do something with. Gotta jump. Still walking when we're jumping. So obviously that's something that we need to do, is that if we're not on the, we're actually not on the floor, we should just have our left leg that's not on the floor go forward, but then not swap. Whoa. Polyoptimism. Don't know what I'm doing with my life. I feel burned out. Give me some tips for work. I don't know. Burnout is not a fun thing. So I hope you get through that, buddy. All the advice that I can give you is take it one step at a time. Okay, so the climbing is, there's still problems. I know I struggle with that from time to time, where you just feel that there's too much to take care of. And all you can do is just take it one step at a time and get through things and hope that things will improve. So why does it do this? Why does it think that we don't need to step up? Why is it not doing that? What's causing it to do this? Feet are on the ground. Here we're going good. then right at the edge, we are failing. And the only thing that I can think of right now is because we got our raycast slightly more forward, we must be getting our raycast straight through. Or maybe when the raycast starts inside of the box, because here of course we got the problem that we are allowing I think we actually need to do a raycast at the front of the foot and at the back of the foot. Because we should really not allow it to have the points of the feet in there. And this is the problem that I have, that we don't have the ability in Godot to have multiple returns. Because what I really want to do is with our test raycast is to not just return a transform, but also return whether we're colliding or not. Unless we're just not going to return a transform here. And check for that over here. Because that's really what looks best. Does the script have a writable parameters? All right, so here we got, are we hitting something? Mm-hmm. The other thing that we could do here actually is not do intersect ray, but do intersect shape. So that we can actually test for a larger area instead of just. Yeah, I was thinking about an array where well, it's either no returns or one return, just to make it yeah, or indeed a data model. We've got a shape query parameter. Oh, that's just testing if a shape at a location has. Okay, so we definitely need to do. Okay, so one thing that I really want to do right now. This is where I am going to make a bit of a inverse global transform. Okay. And now at my start of my physics process, there we go. The reason I want to do this is because it's actually fairly expensive to do an inverse global transform. So having that ready to go makes life a lot easier. Yeah. All right. So now what I really want is I want to have a vector 3. No, actually, I want to have an array. Vector 3 array. All right. All right. Oh, not is. There we go. And then we're going to go and do return rets. Perfect. Yep. All right. So now I want to go and put these collisions in local space. What we're actually going to be doing here is how many ones do I want to do? Because right now we're doing. Why does it keep doing that? Actually, I can get rid of you too. Oh, did I just delete things from the wrong one? No, I didn't. Don't know. Okay, so that's fine. So that is now there. So do I just want to do one raycast here and then one slightly more forward? So there's no really. Just want to see. Move that here. (1,5). That's -1,5 on the z-axis. Interesting. Okay, and if I do the same for the right foot, that's also 0,15 on the. Okay, so we're just going to do 2 raycasts instead of 1. Okay. So in this case, I actually want to go and do ret stop push back in global transform times collision position. There we go. Now we're going to do a second one here. These should actually still be the same. So here we can simply say plus is z times 15 plus is Z. Actually, that needs to be minus 15. Okay, so now we have a raycast on the back of the shoe and on the front of the shoe. We're going to collision again. So now we have a pushback. So now we have 1, 0, 1, or 2 collisions local there. All right. And what I now want to do is if ret dot size bigger than 1, then actually this needs to be while. Now there can only be v2. Oh, if var position. Actually, I'm going to make that. Yeah, plus vector 3 is collision. No, ret dot pop back. So basically, we get the last one that we added. Oh, there is no pop back in vector. Okay, that's interesting. So we do have a pushback, but we don't have a pop back. Okay. You know what? I'm going to return these as is. So this is going to do, if we have collisions at our target transform adjusted beats, returns an array of collisions and local to R. Okay. All right, so now, cool. So this is now going to be far collisions s, please. Is that, so we're going to get a series of collisions here. Is colliding false if collisions is empty, not for false vector 3 is vector 3. There we go, just at 0. No, for collision in collisions. We're gonna do that with a vector 3 in collisions. If collision dot y bigger than pulse dot y, pulse is collision. So now we have the bigger one. Okay, and now we're gonna say target transform dot origin is global transform transpose. All right, cool. So that now puts it in the right spot. All right. Now, one of the things that I also did want to do at some point is adjust the normal. So then we might need to actually build on top of this and get even more data back. So that it might become a array of a dictionary, but or a class is probably better. Where we then put all the data in, both positions and normals, and then return that, and then base it on that. Anyway, we now have that. We now have an is colliding. So now we can do, a var oops is on 4. All right, so now we're going to do at the end of our thing here is is on floor is declining, which now means that down here, instead of all this, we're actually going to say is on ground. Avatar is on ground. On floor is actually on the floor. On the floor, which now means scroll. We should no longer be needing these ones. I hope. Give me any errors. It is. Why? Where am I still using it? Oh yeah, because I'm off. Why did I do that on the left foot magnets? No, left foot magnet is. Oh yeah. Oh damn! I deleted the wrong ones. Like, what has that have to do with array casts? All right, are you happy now? Now he's happy. So that means that I should be able to remove you and remove you. And now let's hope that we didn't break everything again. Yes, we did. It just goes through the floor. Okay, what are we doing wrong now? Where are you? Because I never set this to true. Sure. Okay, what about now? Yay, now we're on the ground. What the heck is that? Where did that come from? Huh? Okay, let's just at least see if this song is working. Kind of. It looks like we messed something else up now. I wonder why it made the step size different. There. Oh, well, first of all, because my position is in the wrong axis. And second of all, we're now moving our foot forward depending on where we're hitting. Huh. That's interesting. Okay. need to undo this offset. It's also in the wrong direction. It's going to be hard to figure out where that is. It's so annoying when things are not. Why is it like that, actually? Let's have another look. So this one has no rotation. So Z is backwards. Looks good. And that one was back by minus 15 on the Z-axis. But all of a sudden that was sideways. Hey, Reckley, how you going? I'm getting tired and my mind's not working very well anymore. I'm trying to figure out this last piece of the puzzle. And for some reason, my raycast looked like it was going in the wrong direction. Target transform basis. So that is all in global space. That should be the target for a foot. So that should be Z. So why is it not moving that forward? Okay, one thing, well, you know, it's always something that we can try. So, no, we're just going to add a new mesh instance 3D. Call it test. That's going to go and have a sphere. Sphere, and that needs to be a small sphere again. 5, 0.1. Hopefully that's visible enough. Yes, it is. Cool. Means we're also going to put that on the right foot. Perfect. We can go back to script. All right. Well, I got it right for Chase. That doesn't happen very often. Let's add that. Let's add that. Well, we only have a transform here, so I'm just going to go and put that over there, and I'm going to remove that guy. And what I'm going to be doing here is I'm going to remove our offset again. But I'm also going to say $test.global. Oh, and I actually want that to be, where are you? Transform top level. No, that's going to be global position is query from. So we can visualize where our raycast is coming from. Okay, I think that I realized that there is one more problem with this, because here we're actually querying whether, oh no, because we're only updating it when we're actually starting our thing. So, okay. Okay, so that does look correct. Kind of working. This is actually kind of funny that it's because the right foot, it's giving more, you can give more strength to the right foot because it's higher up. we bounce around a bit, but it's kind of working. Yeah, it does when I'm moving too fast. It does have its moments where he sort of loses strength. The run is still hilariously broken. But for the most part, this is all working. Yeah, that's kind of okay. We can do squats. Debugging. Yay. All right. I still think that the going up is not strong enough. Let's magnify that some more. Okay, I also don't know why when he's jumping, he's putting his feet together. I'm not quite sure where that's coming from. It's still not making any sense. But I'm too tired. I think that is going to be for another stream. I just want to get my test thingy out of here. So now our dollar test, we don't need that. We now know that that is working decently. Don't need these helper nodes anymore. And I want my tests on the magnets to go away. Don't need those anymore either. But I think at least the walking is a lot better than it was before. Still not quite happy about the way that he turns, but I think that's in part that we're not naturally turning that way. I think we do need to sidestep a bit. Well, let's do that last, because that was something that I did really want to put in here. And especially since this is now all local, what I wanted to do here was actually rotate the target origin. Transform dot origin is actually I need to go and come on, go away. Rotate faces with faces dot rotated. Oh, that's not like this. So vector 3 dot up e angular velocity times y time left. That probably needs a factor in there. But let's just start with that and then rotate times that. Let's see how bad that's going to look. Okay. It's hard to see what it actually is doing right now, whether it's doing something sensible or not. It feels very jerky. I'm wondering if it's rotating the wrong direction. Let's do that in reverse and see if that looks better. I don't know. Go away. I think that's definitely rotating the wrong way. In theory, that should be it, but no idea if that makes it better. No, that makes it way worse. Oops. I don't think this is what we're looking for. Although I think one of the things that probably, I wonder what would happen if I do transform target transform basis is that. And now I add that in. Does that make a difference? It doesn't look at all like it's doing what I'm expecting it to do. Now, it is still possible that we got our linear rotation calculation wrong. Because I'm not using it really anywhere. It might be that this needs to be the other way around. I always forget that. Actually, I only did it once, but still I'm going to be I'm just going to grab the one that I already calculated. That does not make it any better. Whoa. That is definitely screwing it up. So I think that it was the right way around. Oh, what? Ah! I am changing the wrong one. So that was correct. Last transform basis inverse. So maybe this needs to be the other way around. No, that completely looks wrong. I'm too tired for this. We really need to output this and debug it and see if it makes sense. I don't know if it does. But I think that's for another day. Generally speaking, I'm pretty happy with what it is that we accomplished today. It's definitely an improvement on what it was before. While there is still some improvements to do in the jumping mechanic, and I still don't know why the jumping does that. That makes still no sense at all. I have no idea why it is doing that, but that too is something that we will fix another day, not right now. the height should still be a bit higher, I think. I can't stop tweaking. Okay, step curve. Height curve. Yeah. Not even sure if that makes sense, though. I don't know. I need to tweak it so much more. But with all those curves, there is a lot of tweaking to do. I'm still not happy about. And again, I don't know if this is just because I'm rotating faster than I can when I'm stepping like that. That if we are rotating like this, I actually need to make the step size quicker. Because in real life, we might not do it that way. I don't know. Okay, that's our Y. We are... I still don't know why he's getting his feet together at this point, because our offset isn't changing. But obviously the falling logic is not working correctly. And I think the reason why is that we're doing the on ground check here. And we're actually we're doing our raycast all the way down. So we're starting higher and then we're ending lower. And I think that actually the two should just be on the floor. Okay, let's see if that makes a difference. Yeah, now we're jumping. So when we're jumping, we're still doing some weird things with the leg. So something that I need to start checking for is that when we're jumping, so basically the logic should be that when we don't have a collision, we don't have anywhere where our feet can step down. Okay, so that's the problem that we're getting right now. So I think that raycast does need to go a little lower. To allow us to take a step down. But I think we need to get the is colliding for both feet, because it definitely is struggling there. And if we detect that we're actually moving to a lower step like this, instead of it completing the step and then falling, is that we're actually yeah, so I'm gonna first of all, I'm gonna actually do let's go to this, but I'm actually not gonna do that. I'm gonna do this a little bit down. So let's say that the maximum that we can step down, and this needs to become a setting. Is a setting. And then here, let's see. Oh, that's good. Magnet position, that's good. Change the below. Check both feet for colliding correctly. Handle. Correctly handle stepping downstairs. So basically, unless both feet are on the floor, if both targets are on the floor, we're going to take the lower target to handle with this. Yeah, so here, actually it's going to be over here. Just below. We're actually going to do. Oops. Check that lower feet. It's actually going to be interesting if we walk off a cliff. Yeah, so here we want to go and get both. Probably would ragdoll something like that in this case, but that's part of what I still want to change on this, what I haven't even touched. And it kind of is the same as with jumping, right? Right now, the whole thing, it's always running an animation for walking. But basically what I want to do is when you're standing still like this and you're not moving, you know, at this point, it should detect I'm not moving anymore, I'm standing still. So I need to go for an idle animation instead of doing the foot until I start moving either by walking or by rotating. Again, we need to make that work better. I think when we rotating, I should move the feet somewhat more outward. We definitely need it to go closer on the feet much more early. It's very ugly that it immediately does that. Not sure why it doesn't immediately go and get the offset right. But same with jumping, right? Right now with jumping, when we're jumping, we're actually still doing the walk animation. We're trying to do the walk animation in the air and sort of not knowing what to do about it. But the moment that you jump, the moment that we're in the air, we should actually change the logic. We should have a logic where it's going to try and land on one foot, whatever foot we're last moving. So we basically, especially when you do that, boom. So yeah, there it already goes completely berserk. But it should figure out that when we leave the ground, is that it stops doing the animation. And I guess in that case, that if we're actually off the ground at this point in time, we should probably just stop. We should say like, okay, we're not going to do anything. So maybe even we do something like this. Is colliding and that. So now obviously, see now it stops doing that. It's actually already a lot better. So this tries to land on the foot that we're last moving. And because we're no longer having any feet on properly on the ground, it nicely is falling there. So, and again, I do think that I need to, I might need to redo the raycast because because this is the problem that I have right now, right? Because it is, it still sees this as on the ground. It is now saying, oh, that means I'm not falling. So I'm not going to fall. But this foot is not on the ground. So we're now in a position where it's not finishing our jump thing. So, yeah. And this is, I think, the bit of logic that I still need to finish. But it's really, guys, it's 1:30 for me. I have work tomorrow, so I'm going to call it there. I am fairly happy with how far we got with this. I think it's a big step forward to what the logic was that I wrote before. It's a lot of tweaking that we need to do. Probably with some of these, I've gone overboard. So at some point, I think I do need to revisit what we're doing with these curves and sort of say, okay, are they really what they need to be? And then just work from there. So yeah, but I think the first thing is to finish the falling logic. Basically check this logic properly. Yeah, I do think that I need better logic to detect whether the feet are on the ground, because right now I'm doing it based on the target. So maybe I will reinstate the raycast and maybe add a few raycasts more. But it's going to have to be the raycast from the foot that is currently moving towards being on the ground, I think. Yeah, that's going to be the challenge. Anyway, we'll figure it out next time for another day. All right, everybody. Thank you for joining me on the stream. Hope you picked up some interesting little tips and stuff. Once we have this completely working, I'm planning to strip it out of this project and probably just upload it for people to play around with. This is by no means anywhere near production ready. It's really just an experiment at this point in time, but at the same time, it's a feasible solution. It's a good beginning. So we're going to continue with this when I next have time to stream. I don't know when, probably next weekend. We'll see. So yeah, hope to see you next time. Goodbye, everybody.